Cubic spline interpolation. The most common piecewise polynomial approximation uses cubic polynomials between each successive pair of nodes, and it's called cubic spline interpolation. And a general cubic polynomial involves 4 constants. So, ito yung S sub j of x equals a sub j plus b sub j times x minus x sub j plus c sub j times x minus x sub j squared plus b sub j times x minus x sub j cubed, which is a sub j and b sub j, c and j sub j and d sub j. Yun yung mga hinahanap na constant natin, na unknowns, 4 unknowns. The cubic spline procedure ensures that the interpolance is not only continuously differentiable on the interval, but also has a continuous second derivative. From the linear and quadratic spline explanation, we set conditions for a natural cubic spline as follows here. S sub 1, rather I of x is at most a cubic in each subinterval, which is x sub 1 minus 1 and x sub I, which is I equals 1, 2, and so on and so forth. And S sub I times x sub I equals y sub I, which is I equals to 0, 1, 2, and so on and so forth. And S sub I type of x and S sub I prime of x and S sub I double prime of x are continuous in x sub 0 and x sub n. And last is x sub 1 double prime of x sub 0 equals S sub I double prime of x sub n is equals to 0. Before I go into the example, here it shows the difference of linear spline, quadratic spline, and cubic spline, which is cubic spline is continuous first and second derivatives and smoother. And we're going to the examples for the cubic splines for more information and you to understand. Example number 1. Construct a natural cubic spline that passes through points 1 to 2 and 2 to 3 and 3 to 5. First, kukuhain natin yung interval na 1 to 2. 1 to 2. In this first interval, meron tayong equation na S naught double prime of x equals a naught plus b naught x minus 1 plus c naught x minus 1 squared plus d naught x minus 1 cube. So this is the first equation. So, sa second interval, which is 2 to 3, 2 to 3, we have equation S sub 1 of x equals a sub 1 plus b sub 1 x minus 2 plus c sub 1 x minus 2 squared plus d1 x minus 2 cube. So, sa makikita nyo, meron tayong 8 unknowns, which is apat sa S0 of x na A0, B0, tsaka C0, and D0. Sa S sub 1 of x is A1, B sub 1, C sub 1, and D sub 1. So, meron tayong 8 unknowns. To determine the 8 unknowns, we have 8 conditions. So, let's start. Dapat na condition is makuha natin na the spline must agree with the data at the nodes. So, ang S sub not double prime of x is equal sa f of x. Then, yung S sub 1 of x is equal sa f of x. So, sa interval na 1 to 2, pwede natin siya makuha sa S not double prime of x is equals of f of x, which is, yung x is 1. So, we can substitute this to 1 as S not double prime of 1 equals f of 1 equals, substitute natin yung 1 sa kada x. So, equals sa a not equals to 2, which is, kapag sinubstitute natin yung 1 sa kada x, 1 minus x equals 0. So, cancel. Then, 1 minus 1 squared equals 0. Then, cancel. Then, this one is cancel also. So, meron na tayong first equation. So, sa 2 naman, pag sinubstitute natin sa kada 2 yan, S not 2 equals f of 2 equals, so 2 is 1, then nagiging 1, so S naught plus B naught plus C naught plus D naught equals to 3. Which is yung 1 to 2, yun to yung ginamit natin. So, ang makukuha natin is yung 3. Yung kanina is 1 yung kinuha, sinubstitute natin, ang nakuha natin na answer is 2. So, pag sinubstitute natin ang 1, makuha natin is 2. So, pag sinubstitute natin is 2, ang makuha natin is 3. Then, ganun din sa may interval na 2 to 3. Pag sinubstitute natin ang 2, ang makuha natin ay f of x equals f of x is equals to S of 2 equals f of 2 equals, substitute natin kada 2 sa bawat x. Ang answer is a1 equals to 3 because 2 minus 2 equals 0. So cancel, then cancel also, and then cancel. So ang matitira is 3 a1, which is 3. Then sa pag kinuha na naman, pag sinubstitute naman natin is 3. Ano natin is sub 1 of x equals, which is s sub 1 of 3 equals f of x equals, substitute natin sa kada x ang 3. Ang magiging sagot is a1 plus b1 plus c1 plus d1 equals 5. Try natin. 3 minus 2 equals 1. So b1, 2 minus 2, 3 minus 2 squared is 1. This one is 1 also. So sila is a1 plus b1 plus c1 plus d1 equals to 5. So meron na tayong 3 equations. This is 2 and this is 3. This is 2, I mean, and this is 3. This is 4. We have 4. Then we have 4 more, and for derivative, ang makukuha natin is derivative natin yung s naught double prime of x minus a naught, and so on so far. We have get s naught prime of x equals b naught plus 2 c naught minus x sub 1 plus d x minus 1 plus 3 d1 times x minus 1 squared. Cut. So sa derivatives natin makukuha ang the rest equation. So pag derivative natin ang interval na 1 to 2 is equal sa s naught prime of x equals to a1 is cancelled, then matitira is b naught plus derivative ng c naught times x minus 1 squared equals to 2c naught times x minus 1 plus derivative ng d naught times x minus 1 cube is 3d naught times x minus 1 squared. Then derivative ng 2 to 3 is s sub 1 prime of x equals to cancel, then matitira is b1 plus derivative ng c1 times x minus 2 squared equals to 2c1 x minus 2 plus derivative ng d1 times x minus 2 cube is 3d1 times x minus 2 squared. And then their first derivative ay second derivative ng 1 to 2 is equals to a naught double prime of x equals to cancel equals to Ito na tayo kumuha para mas madali. Is 2c naught plus 6d naught times x minus 1. Then, second derivative na itong is s1 double prime of x equals 2c1 plus 6d1 x minus squared. So, as mapapansin natin is equal sila because yung node na kinukuha natin, yung common node nila is yung 2. So, kapag sinubstitute natin yung 2 dyan is equal sila and then 3. So, kapag kinuha natin is s naught prime of 2 is equals to s sub 1 prime of 2 equals sa b naught plus 2c naught plus d naught equals to b1. And then, so, ito na yung fifth equation natin. And then, this one is not double prime of 3 is equals to s1 double prime of 3 is equals sa 2c naught plus 2c naught plus 6d naught is equals to 2c1. So, meron na tayong 6th equation. Then, yung 2 more equation is makukuha natin sa natural boundary condition. Sa natural boundary condition, meron tayong s naught double prime of x is equals to s sub 1 double prime of x is equals to 0. Then, kukuhain natin yung first node and then yung na last node. Substitute natin is s naught double prime of 1 equals to 0, which is 2c naught equals to 0. Yung sa s1 double prime, yung last node is 3 is equals to 0, which is equal to 2c1 plus 6d1 equals to 0. So, ito yung 7th equation and then yung 8th equation. Para makuha natin yung simultaneous equation. So, from the equations na nakuha natin, we can solve simultaneous equation condition na unknowns is naught, b naught, c naught, d naught, and a sub 1, b sub 1, c sub 1, d sub 1. The answer is a naught is equals to 2. Then a1 is equals to 3. And from this, c naught is equals to 0. If we solve the unknowns from the equation, d1 is negative 1/4. Then d naught is 1/4. c1 is 3/4. Then d1 is 3/4. Then d naught is 3/4. So, ang equation ng spline na to is makukuha natin s of x equals from this equation is 2 plus 3/4 x minus 1 plus 1/4 times x minus 1 cube 4 x, interval of 1 to 2. Then sa interval 2 to 3 is 3 plus 3/4 times x minus 2 plus 3/4 x minus 2 squared minus 1/4 times x minus 2 cubed for x interval of 2 to 3. That's the example number 1. Example number 2. Find a, b, and c that make this a cubic spline of these two functions. Let's solve for these two functions. S of 1 of x equals 2x cubed minus 3x squared plus 3x minus 4. And 0 to the of x, 2 into of 1 to the let's substitute the 1. S of 1 of 1 equals 2 of 1 cubed minus 3 times 1 squared plus 3 times 1 minus 4 equals 2 times 1 cubed minus 3 times squared plus 3 times 1 minus 4 equals negative 2. Then gawin natin yung first derivative. Then substitute the 1. S of 1 prime of x equals 6 times 1 squared minus 6 times 1 plus 3 equals 6 plus 3 equals 3. Then yung second derivative, 12 times 1 minus 6 equals 6. Then yung second function, kuhain din natin. Substitute natin yung 1. S2 of 1 equals 1 cubed plus a times 1 squared plus b times 1 plus c equals 1 plus a plus b plus c equals negative 2. And then the first derivative, lagyan natin yung 1. 3 times 1 squared plus 2a times 1 plus b equals 3 plus 2a plus b equals 3. Then second derivative is plug in the 1. 6 times 1 plus 2a equals 6. So we get the 3 equation and 3 unknown, which is 1 plus a plus b plus c equals negative 2, and 3 plus 2a plus b equals 3. 6 plus 2a equals 6, which is a equals 0, b equals 0, and c equals 3. Example 3. Last example of cubic spline. Find a to make cubic spline and natural cubic spline. We're given a function of s of 1 of x equals to 0. Then 0, then x, and then 2, 1. We plug in 1 to this function. We're going to get the first derivative and second derivative. S sub 1 times 1 equals to 0. Then the first derivative is equals to 0 also, and the second derivative is equals to 0 also. Then the second equation given is S sub 2 of x equals to a times x minus 1 cube of 1. Dito is yun din yung gagawin natin sa second function na given. S sub 2, lagyan natin yung 1. Then a equals a times 1 minus 1 squared. 1 minus 1 cube equals 0. Then the first derivative is also, it equals to 0. That's the first derivative, and that's the second derivative, and also this is equal to 0. So a can be anything. Then next is we're going to find the natural cubic spline. If first derivative of x sub 1, the end point is 0. Is second derivative of s sub 1 of 0 equals to 0. Then we'll also test the second derivative of s sub 2 if at the end point is 0. So second derivative of s2, plug in the 2, equals 6a. 2 minus 1 equals to 0. So 6a equals to 0. And a equals to 0. So that's it.